Hello, my name is Akhil. I'm a first year undergraduate student studying physics. In this video, I'll be discussing the theoretical concept of gravity trains. Gravity trains were first proposed by Robert Hooke in a series of letters to Isaac Newton. It's a very interesting problem with an even more interesting result. So let's draw the diagram and get a view of what the problem is trying to say. This is the Earth. These are 2 points, two arbitrary points connected by a tunnel, very thin tunnel. P is the center of the Earth. This is B. This is point X, the temporary position of the point particle when released from A. This distance is R. This distance is X. Let the blue sphere denote B of radius R. So when the point mass particle is at position X, the sphere of radius R will attract this point mass particle as if its center were at P. So we have to, so first to get to the interesting answer, we must first figure out the forces acting on the point mass particle. So the force acting on the point mass particle is, assuming this angle is phi. So in this situation, the force acting on point mass particle is gr cos phi. Gr is the gravitational acceleration at a distance r from the center of the Earth. So first we should try and calculate the value of gr. The force at the surface of the Earth due to gravity is g capital M small m by re square. Assuming that the entire sphere, that is the Earth, is of constant density, capital Me is equal to rho times V. So, so, so we have to figure out what will the mass of a sphere of radius r be of the same density. That is rho times V times r, V of r. V is volume of r. So rho is capital Me by 4 by 3 pi re cube times 4 by 3 pi r cube. 4 by 3 and pi get cancelled. This is Me r cube by capital E r cube. So the force acting due to gravity at a distance r from the center of the Earth would be g capital M r small m by r square. On substituting this value, which is the value of mr, inside this equation, we get F equals g me r by re cube. So m gets cancelled out. So this implies that g at r is g capital M R sorry, capital MR is no longer there. Now capital R is there, small r by RE cube. On further observation, one can see that Gm by Re square, sorry, this was Me, right? This was Me, Gmer by R cube, and Gme by Re square is nothing but G, which G is the gravitational acceleration due to gravity at the surface of the Earth. So hence Gr, the value of Gr is G small r by capital Re. So now we know the value of Gr. So uh, as we said earlier, the acceleration at point x on this mass would be Gr cos phi. Now Gr is nothing but Gr is R by Re times G times cos phi. Using Pythagoras theorem, R can be written as root over x square plus b square. So, so this is acceleration actually, the acceleration at point A. So therefore, on substituting this value over here, we get acceleration is equal to root over x square plus b square whole upon Re times G cos phi. But cos phi is equal to R by X. Cos sorry, not R by X, but X by R. So acceleration becomes A equals root over X square plus B square whole upon Re times X by R times G. Now R and this term gets cancelled out since R is nothing but X root over X square plus B square. So this implies that the acceleration at this point turns out to be X by Re times G. This is a very interesting result since since A is equal to A is A is equal to X by Re times G, and A can be written as d square X by dt square. This is equal to minus X by Re times G. Now how does the minus come about? It can be also very intuitively observed that as this particle moves closer and closer to this point, the force is decreasing, and as it moves away from this particle, the force starts acting this way. Since now the larger portion of sphere lies on this side uh, and not on this side. So as the particle approaches this point and this point, the entire position, the direction of which the force will be acting is opposite. So one can see that the direction of force is opposite to that of displacement. So now that we get this equation, d square x by dt square is equal to minus x times g by re, we can compare it to the SHM equation derived in classes earlier. So on comparing them to the SHM equations, we can figure out that omega, which is the angular velocity, is equal to root over g by re, and t is the time period, which is equal to 2 pi by omega is equal to 2 pi root over re by g. Now the most interesting conclusion one can derive from this expression, and the entire essence of this problem, is that no matter what these two arbitrary points are, these two arbitrary points could as well be this and this, or this and this, or even this and this. No matter how far they are separated from each other, this and this, this and this, you can clearly see that they differ in size. This is definitely longer than this, and intuitively one might feel that the time taken for a particle to fall from this point to reach this point will be greater than the particle traveling through this tunnel. So as it turns out, the time period taken to complete one entire motion, that is from point A to point B, on any of these lines is the same, and is not dependent at all on the points, is only dependent on the radius and the gravitational acceleration at the surface of the Earth. On calculating the value of this, it turns out to be the time period approximately turns out to be 2532 seconds. So isn't that interesting that no matter what point you choose, it could be completely opposite to each other, passing through the center, or very close to each other. But as long as it is moving from within the Earth and there are two arbitrary points, they will always take 2532 seconds to reach from one point to the other. So this is what the concept of gravity trains was, and that's it. Thank you.